we are back with some quick math. This is the PLC paper that you dealt with. This is some trig. Well, we're going to use some identities over here. We're going to do some reductions. Here we might use our compound angles, but let's see how it goes. Okay, great. So as we've mentioned, there's a negative here. In our Cartesian plane, we know that a negative angle puts us over here. So we know that that is C-A-S-T cos diagram. Negative puts us in our fourth quadrant. So this is going to reduce positive. That's going to give me positive cos theta. Okay. Here I've got a 90 minus. So we know 90 minus puts us in our first quadrant. 90 is over here, 90 minus is first quadrant. So this is going to reduce positive, right? Sine in that quadrant is positive, so this reduces positive. 90, because I'm dealing with 90, we know that sine and cos are co-functions. So sine is going to change to cos, and this will give me cos of theta. Okay, so what did we just do? 90 minus, that's in this quadrant. Sine's positive there. This changes to positive because it is sine. It changes to cos because of the 90. They are co-functions. Great. Then we have this bracket over here. This is an identity. I don't think we deal with it, right? But let's deal with the tan. So we know tan is sine squared theta over cos squared theta, right? So let's go rewrite this. Let's say this is 1 plus sine squared theta over cos squared theta. Here we have a number time or plus a fraction. We know we want to have both of them as fractions. So 1 we're going to change. We know that 1 can be anything divided by itself. So 1 we're going to make, let's say, cos squared theta divided by cos squared theta. Right? Anything divided by itself is still 1. This over here is going to give me cos squared theta. The 1 we said we're going to change to cos squared theta over cos squared theta. Why did we do that? So that our denominators can be the same. So we can add these cos squared theta. Right? Denominators are the same now, so you can add your numerators. Let's leave this outside here. Cos squared theta. Cos squared theta plus sine squared theta. All of this over, cos squared theta. Great. This is over 1, so we know that that can cancel that. This is from our square identity equal to 1, so all of that reduces to 1. Great, let's get straight into 5.2. They give us this identity, and they ask us to, from that identity, derive this one. Okay, so let's start with this. Let's say that sine A minus B, this is the one that we want to prove, right? Now we know that this is equal to cos of 90 minus whatever is in here. Similar to the identity we use above here. So this is going to be 90 minus your A minus your B. Okay. Now let's work with this one. And whatever we end up with is going to be equal to the sine A minus B. Right, let's get rid of the brackets first. So let this minus multiply in. So this is going to be cos 90 minus your A. That minus multiplies into become a plus B. Okay, this over here, this part is going to be my A, and that part is going to be my B if I look at the identity that we started with, right, that compound angle. So here we're going to say cos reduces to cos sine sine. So this is going to be cos of this first angle, which we said was A, 90 minus A, times cos of my B. Let's change this. Cos of my B, right? So all I'm doing is I'm going back to this identity that they gave us. This one here. I'm going back there. I'm using that. And I'm saying cos of something. And the something is this whole block over here. Plus the second thing is my B. Okay. And then it's going to be a minus sine of, again, that first thing, which is my 90 minus A. Plus, not plus, times sine of B. Right, great. 90 minus again, first quadrant, cos changes to sine, so this is sine of my A times cos B minus, okay, same thing, 90 minus first quadrant, and that reduces to cos A sine B.